Alright, so kinematics comes up all the time. It's one of those concepts where it applies to real world situations, to mathematics and to calculus. It's really, really valuable. The first thing we need to understand is that we're dealing with motion here. So how length changes with time. That's what motion's all about. When we look at these concepts, the first thing we need to be aware of is some vocab. So you need to be aware of the vocab and be very specific about what the differences between some of these terms are. The first thing we look at is distance and displacement. Now both of those are dealing with length. Okay, both of those are concepts of length. You can tell you're dealing with a distance or a displacement because it'll have units like meters, centimeters, kilometers, miles, those sorts of things. By themselves, just meters, that sort of stuff. Happy with that? So what we probably understand what these concepts are, but differentiating between, well, what is a displacement and what is a distance is probably most easily done with an example. So I'm going to start with my starting point. Okay, I'm going to call this 0 on my origin. It's right here. This is my starting point. I'm going to do a zooming. Ready? I'm going to go for a zoom. I'm zooming, still zooming. I've returned to my starting point. My zoom was 8 meters. My distance was 8 meters. What's my current displacement? 0. So your displacement is your distance from the origin. So it's got a directional component. So displacement will have a directional component, and that will be determined within the question. So it might say the origin, at the origin, left is positive, right is negative. So if I travel a meter to the right, my displacement is -1. Happy with that? Distance can never be negative. Awesome? So distance is like the total length that we've travelled. Displacement is how far from the starting point am I, or the defined origin. It's what we call a vector component. Now vectors need a direction and a size. Distance is what we call a scalar component. We just have a length or a magnitude associated with it. Are we happy with that? Do we understand the difference between those two? If you understand the difference between those two, differentiating the rest is really easy. So speed, in the situation I just spoke about, speed and velocity are how much length changes over a period of time. So units for speed and velocity would be things like kilometers per hour, meters per second, kilometers per second, millimeters per hour, that sort of stuff. Does that make sense? Anything where you've got a length divided by time, and again we're looking for that word per. What does the word per mean? We're dealing with a rate, so it's a rate of change. Speed and velocity are the rate of change for our distance. Cool? Rates are how things change, often over time. With respect to time, very good. So our speed is essentially, in that situation, would be 8 seconds to do my 8 meter zooming. What does the speed of that situation? What was the average speed I travelled? 8 meters in 8 seconds. My average speed was 1 meter per second. My average velocity was? Where am I? My starting point, which means my displacement is? What's my displacement divided by time? 0 divided by 8 is? 0. So my velocity was 0 and my speed was 8 meters per second, correct? Happy with that? Your velocity is like 7.
Yeah. Is that correct?
Depends on the units. 7 centimeters per second, not real fast.
I'm talking meters.
Meters per second.
Exactly.
You.
Moral of the story.
Okay. So the way we can tell we're dealing with a speed is that centimeters per second. What does that mean about how do I go between distance and speed or velocity, displacement velocity? I have to derive, very good. So dt, I have to apply a derivative. Now acceleration is all about how much does my speed change with respect to time, how much does my velocity change with respect to time. The good thing about acceleration, or the good and bad thing, is that there's only one word for both vector and scalar quantity. So if I'm dealing with velocity and I derive that, it'll get me an acceleration. If I'm dealing with speed and I derive that, it'll get me an acceleration. Cool? So we only have one word. It can be either a vector or a scalar. The way that I know that I'm dealing with this acceleration is I'll have meters per second squared or kilometers per hour squared. So my unit of time is squared. Cool? And that's because it is a change in length divided by change in length over time again. Cool? How quickly my speed changes. So if I'm increasing my speed as time goes on, I've got an acceleration. Awesome. If you want to know the difference between speed and acceleration, when you're on a train or in a car, if you're travelling along at 100 kilometres an hour, do you feel any force or anything? No, but when the car hits the brakes, what happens? You move forward.
So, if you're in a train,
Yep.
you jump.
Yep.
Why, if you're on top of the train and you jump, you get yeeted, but not in the train?
Air resistance.
Oh.
Okay.
I didn't know that.
So,
I thought it was just like an unsolved thing.
to get from speed to acceleration, again we derive.
Yes.
Now that's all well and good, but why am I teaching you this after teaching you integration for the last whatever amount of weeks? Why?
To go back the other way.
Oh, very good. So if we're going back the other way, if we're going from acceleration to speed, what do we need to do? Integrate with respect to time. Integrate with respect to time, correct? Now we're probably at the point that I'd make a note of those little arrows. If we're going down the ladder, we're deriving. If we're going up the ladder, we're integrating. Again, if we understand the concept, we don't need to try and rote learn this. We can see, we know that length is measured in what? Meters or centimeters. We know that speed is measured in kilometers per hour, meters per second, correct? So if we understand that, we know that to get between them, it's going to be a derivative. And vice versa, if we need to get the time off the bottom, we need to multiply by, essentially think of it as a multiplication of our dt there. So to go back up, we need to integrate. Awesome? That makes sense? So try and understand it, you won't have to rote learn it.
So the key word is to know if it's speed is like
Total length.
Oh,
Yeah,
okay,
yeah. Like meters per second, that's our unit.
Okay.
But speed's our total length travelled over a period of time, whereas displacement of velocity is that distance from the origin over time. They're often used very interchangeably. As long as you understand that velocity can be negative and speed can't be, but they're very, very interchangeable. But we do need to understand the difference. So we're probably at the point in our mathematics where you'd expect that we're beyond just subbing values into equations. So the reason we need to deal with the most common thing that we're going to have to do at this point in time is we'll be given a velocity equation or a speed, a distance equation or an acceleration equation, and we'll be asked to find one of the other concepts. Cool? So if we're given a velocity equation, we might be asked to find displacement or an acceleration. So what better way to practice than to start with that? Okay? So I'm going to give you this piece of information. Now actually I'm going to add one piece of information as well. We start 2 meters. So this is a direction up. Up is positive. So up is positive. This is a ball being thrown vertically upwards. You probably can tell that by the numbers used in the equation. Positive is up. And we start 2 meters above the ground. So we're throwing it from 2 meters up. So this is our situation.